All right, welcome back. Now we're going to take the example that we had in our last problem where we baked a cake and found out that the mean baking time was 28 minutes and that the standard deviation was 1, which again we can represent as a model that looks like this. And now I want to use it to apply some more useful information or get some more information and show how we can use models to make decisions. So let's suppose that you want to know if when you're baking the cake, you can go on a run and make it back in time before your cake burns up. So you're going on a run and you don't want your cake to become charred and burn up, right? And so the way you're going to make this decision is you're going to know your pace, which for you might be, let's say, a 6-minute and 45-minute mile, which means you are running a mile every 6.75 minutes. And so you need to figure out how long it's going to take you to run 4 miles, which is what you're training for and what you want to look for now. So we're going to try to figure out how long it takes you to run 4 miles and figure out what's the probability that the cake's going to burn before you get back. So the first thing we need to do is figure out how long it's going to take you to perform this run. So if you take 6 minutes and 6.75 minutes per mile, and you multiply that times 4 miles, the first thing you'll always make sure is that your units cancel, which they do, and you'll end up realizing that your run is going to take you 27 minutes. Okay, that's great. So you need to figure out now what is the probability that the cake is going to burn or be ready before 27 minutes. So just as we did before, it's always helpful to draw out what the distribution looks like. So we're going to draw our model again. It's the same model that we did in the last video. So here is 28 minutes, which was our mean and our best guess. And we said that standard deviation was, or 2 standard deviations was about 26 minutes and 30 minutes. So we're just looking at the exact same model that we had before. But now we're trying to do something a little bit different. We're trying to figure out what is the probability that at 27 minutes, so at 27 minutes right here, what we want to calculate is the probability that the cake is done before that 27 minutes. So we're trying to find the area under the curve highlighted in green this time. Well, what we need to do then is figure out what z-score is associated with 27. And the way we do that is we use our handy formula. We figure out our critical value and we subtract our our best estimate, our mean, y bar, and we divide by the number of standard deviations, and that'll give us our z-score. So our critical value here, the value we want to try to figure out if we're going to have enough time, is 27 minutes. And our mean is 28 minutes. So, so that's going to equal -1. Our standard deviation, remember, is 1. We know that from the model that we figured out before, and it's already stated in the model. So we're going to divide by 1. Of course, anything divided by 1 is 1. So we have -1. It equals our z-score. So now we're going to have to do the opposite of what we did before. Before we knew the z-score, we needed to find the probability. I'm sorry, we knew the probability and we needed to find the z-score. This time we have the probability, the z-score, and we need to find the probability. See, it's all very confusing. The way I remember it to try and keep from being confused is to remember that if I want the probability, when I go to R, I'm going to type P and then norm. And then we want the probability at z equals 1, or -1. And so we're going to type that in. And when we do, we're going to get a value back that rounds to 0.016. And what that means is that there's a 16% chance that the cake will burn or be overcooked before you get back from your run. So I guess you better get running, and I will see you next time.